Take a slow, deep breath in, and as you exhale, let your body settle completely into the quiet, comforting gravity of your bed. Tonight, we are journeying into the deep cosmos to visit a celestial masterpiece, drifting toward the heart of the Eagle Nebula, to behold the breathtaking monument known as the Pillars of Creation. Located approximately 6,500 light-years away from Earth, tucked within the winding constellation of Serpens, this colossal structure is an active nursery where stars are born. The world was first introduced to its profound beauty on April 1st, 1995, when the Hubble Space Telescope captured an image so iconic, it forever changed our relationship with the night sky. But tonight, you are not merely looking at a photograph. You are floating peacefully through the very fabric of this space. Imagine the sheer scale of the distance we have traveled. Because light takes time to cross the vast, silent ocean of the universe, looking at the pillars means looking back in time. The delicate photons of light that reach our telescopes tonight began their unimaginably fast journey 6,500 years ago. When this light first departed the nebula, human civilization on Earth was in its infancy, just beginning to invent the wheel and forge copper. You can feel a sense of profound peace in this vastness, a comforting reminder of the grand, slow endurance of the universe. As you drift closer, visualize the texture of these three magnificent towers rising from the dark void. From afar, they appear solid, like towering stalagmites in a cosmic cave. But as you float near them, you can sense their true nature. They are not made of stone or rock, but rather vast, sweeping clouds of cold molecular hydrogen gas and exceptionally fine cosmic dust. In the vacuum of space, this dust feels like a silent, weightless fog. It is composed of microscopic particles of silicates, carbon, and ice, drifting like fine smoke across a beam of sunlight. Consider the immensity of what surrounds you. The tallest pillar, standing proudly on the left side of the formation, stretches for roughly 4 to 5 light-years in length. To truly feel the weight of that measurement, remember that a single light-year is a distance of nearly 5.88 trillion miles. If you were to travel from the cloudy base of this single pillar to its glowing tip at the speed of light, it would take you half a decade. Suspended here, your own physical weight melts away, be replaced by the sensation of floating beside something so ancient and immense that all earthly worries dissolve into the quiet dark. Surrounding you is an ethereal ocean of color, mapped by scientists through the specific elements glowing within the gas. In the famous 1995 Hubble observation, astronomers utilized a specialized visual mapping known as the Hubble palette. In this mesmerizing array of colors, the soft, ghostly bluish haze that surrounds the pillars represents ionized oxygen atoms. The rich, glowing greens trace the presence of ionized hydrogen, while the deep, smoldering reds reveal ionized sulfur. Imagine drifting effortlessly through these veils of light, feeling the silent chemistry of the cosmos washing over you in waves of blue, green, and red. Despite their fiery, vibrant appearance in these images, the physical reality inside the pillars is one of absolute, deeply comforting chill. The gas within these thick towers hovers at an incredibly low temperature of about 10 to 20 Kelvin. That is roughly negative 440 degrees Fahrenheit, just a few fragile degrees above absolute zero. Contrast this unimaginable cosmic chill with the soft, enveloping warmth of the blankets currently resting over your own body. Here's something remarkable about this extreme cold. It is absolutely essential for the creation of life. If the gas were hot, it would expand and dissipate into the void. But in this deep, freezing stillness, the delicate force of gravity can quietly do its work. The cold allows the molecular clouds to become thick and heavy, slowly pulling matter together without the chaotic interference of thermal expansion. It is a dark, a quiet nursery, patiently waiting to ignite. As you float near the outer edges of the towering clouds, you might notice that the pillars are not static. They are being constantly, meticulously sculpted. Just outside the frame of our vision, above the pillars, sits a brilliant cluster of massive, incredibly hot young stars known as NGC 6611. These young, energetic stars are emitting a relentless torrent of intense ultraviolet radiation. This UV light acts like a powerful, invisible cosmic wind. As the radiation strikes the cold hydrogen gas of the pillars, it slowly heats and boils away the outer layers into the surrounding vacuum. This gentle, relentless process of cosmic erosion is known in astrophysics as photoevaporation. You can almost feel the rhythm of this invisible tide of light, a stellar breeze that has been carving and shaping these majestic, dusty towers for millions of years. Much like wind and water, smooth the canyons on Earth. Drift gently upward toward the very tips of the towering pillars. Here, the edges appear frayed, reaching upward like delicate fingers stretching into the starlight. Let your mind embrace the staggering reality of these shapes. Each one of these tiny, fragile-looking protrusions is physically larger than our entire solar system. Hidden inside the tips of these dusty fingers are incredibly dense pockets of gas, known as evaporating gaseous globules, or EGGs for short. It is within these dark, microscopic-seeming EGGs that the magic of creation is currently happening. And the denser gas inside these globules acts as a protective shield, defending the delicate forming stars within from the eroding ultraviolet radiation of the cluster above. It is just like a heavy boulder in a river, sheltering a small patch of calm sand from the rushing current. Safe inside these eggs, gravity gathers the cold dust, packing it tighter and tighter until the pressure sparks nuclear fusion, and a new star takes its first breath. Our understanding of this silent, beautiful process deepened immensely in the year 2022, when the James Webb Space Telescope turned its magnificent golden mirrors toward the Eagle Nebula. Webb views the universe differently than human eyes. It sees the cosmos in near-infrared and mid-infrared light. Infrared light has longer, more sweeping wavelengths than the visible light we see. These longer waves possess a remarkable ability. They can slip cleanly through the microscopic grains of cosmic dust that usually block our view. When scientists looked through Webb's near-infrared camera, the seemingly opaque, impenetrable walls of the pillars suddenly became beautifully translucent. Imagine the curtain of the universe being gently pulled back just for you. Through this infrared vision, thousands of newly formed stars, previously hidden deep within and behind the thick dust, suddenly became visible. They appeared like glittering, perfect diamonds, suspended in a delicate web of gossamer light. The darkness was filled with the soft, glowing evidence of stellar life. As you observe this newly revealed landscape, you can see brilliant, crimson-red glows at the edges of the dust clouds. These are not just painted colors. They are the signatures of deep kinetic movement. These vibrant red patches are known as bow shocks. They occur when supersonic jets of energetic hydrogen molecules are violently ejected by newly forming stars, known as protostars. As a baby star gathers material, it shoots out narrow, powerful jets of matter from its poles at speeds reaching hundreds of kilometers per second. When this incredibly fast material crashes into the cold, sleeping gas of the nebula, It creates these brilliant red shock waves. It is a slow-motion cosmic dance, rippling through the dark, much like the physical wake of a quiet boat, moving smoothly through a dark, still lake at midnight. Floating here in the comforting void, surrounded by the invisible push of starlight and the gentle pull of gravity, you consider the sheer mass required to orchestrate this magnificent display. The pillars of creation contain an estimated mass roughly 200 times that of our own sun. Yet, all of this material is locked in a slow, silent, perfectly balanced ballet. Feel the absolute weightlessness of your own awareness as you drift near such immense ancient mass. The gravity in this nebula doesn't pull with sudden urgency or chaotic force. It whispers over millennia. It is a slow, methodical gathering of elements that requires hundreds of thousands of years of perfect patience. You are a witness to the universe taking its time, crafting beauty without a single sound in the peaceful, endless dark. Continuing our journey through the quiet stretch of space surrounding the Eagle Nebula, we sink further into the deep, enduring timeline of human curiosity. To fully appreciate the silent grandeur of the structure before you, trace the history of how our ancestors first reached out to understand this distant pocket of the cosmos. For thousands of years, the stars above this nebula were witnessed purely as pinpricks of light, nameless and unreachable. It was not until the year 1745 that a Swiss astronomer named Jean-Philippe de Chezeaux aimed a rudimentary telescope toward the winding stars of the constellation Serpens. Through his antique lenses of ground glass, he documented a luminous cluster of young stars, which we now formally recognize as NG C6611. Yet, the magnificent towers of dust we are drifting beside tonight remained completely invisible to his eyes. The ambient light of the gas was simply too faint for the optics of the 18th century. A curious detail emerges a few years later, in 1764, when the legendary French astronomer Charles Messier independently observed this same region. He diligently recorded it in his famous astronomical catalogue as Messier 16, or M16 for short. Messier, too, could only discern the bright, hot stars. For over a century afterward, the towering dust columns kept their shape hidden in the dark. It required the technological leap of astrophotography to pull their silhouettes from the void. In 1895, the pioneering astronomer E. Barnard utilized long-exposure photographic plates to finally capture the first ghostly, sweeping outlines of the wider nebula. Picture this entire cosmic ecosystem as early astronomers eventually mapped it. The broader Eagle Nebula is incredibly immense, spanning roughly 70 light-years by 55 light-years across. If you were to trace its perimeter, you would find a shape resembling a majestic bird of prey, with its wings spread wide against the dark. The pillars we are currently observing occupy only the very center of this massive formation, serving as the inner talons of the eagle. The total mass of the entire Messier 16 nebula is estimated to be approximately 32,000 times the mass of our Sun. The pillars themselves, containing roughly 200 solar masses, represent just a tiny, beautiful fraction of the whole. What's happening now is a closer inspection of how these specific columns physically came to exist. Astrophysicists formally classify structures like the pillars of creation as elephant trunks. To understand how an elephant trunk forms in the vacuum of space, think of a river on Earth. Imagine standing in a shallow, softly flowing stream. But if you place a sturdy pebble in the water, the current naturally parts around it. Directly behind the stone, a long trailing ribbon of undisturbed, calm water remains, shielded from the force of the river. The pillars form through exactly the same physical mechanics, operating on a cosmic scale. The intense ultraviolet radiation from the NGC 6611 star cluster acts as the rushing river. The incredibly dense knots of cold gas at the very tips of the columns act as the protecting pebbles. These dense knots shelter the lighter, more fragile gas trailing below them, casting long three-dimensional shadows of material that the stellar winds cannot blow away. Notice how thick and opaque the dust appears as you float alongside it. It seems as solid as a mountain range. However, this is an elegant optical illusion born of immense scale. And deep within these structures, the environment is profoundly empty. In the densest regions of the molecular clouds, there are approximately 10,000 to 100,000 microscopic particles per cubic centimeter. To ground that number in reality, consider that the air you are breathing right now on Earth contains roughly 2.5 quintillion molecules in that exact same cubic centimeter. The thickest, darkest heart of the pillars of creation is actually a harder, more perfect vacuum than the most advanced artificial vacuum chambers ever constructed in terrestrial laboratories. You are gliding through a space of almost absolute nothingness, where the delicate particles are just numerous enough to catch the light over trillions of miles. Scientists discovered even more about the nature of these solitary particles in 2007 using the Spitzer Space Telescope. Spitzer was designed to capture thermal emissions in the mid-infrared spectrum. When it turned its sensors toward the Eagle Nebula, it detected the distinct glowing signature of specific chemical compounds known as polycyclic aromatic hydrocarbons, or PAHs for short. The chemistry of PAHs is intimately familiar to us. On our home planet, these complex organic molecules are created through combustion. They are the exact same microscopic compounds you would find in the dark soot of a dying candle, the charred edge of a piece of burnt toast, or the lingering smoke of a campfire. Drifting through the absolute zero of the universe, surrounded by the quiet hum of forming stars, the pillars are laced with the same organic chemistry that scents an autumn evening on Earth. The dust grains themselves are astonishingly small, measuring about 0.1 micrometers across, roughly the same diameter as a particle of fine smoke. At this very moment, as you observe the tranquil silence of the scene, you might assume the columns are perfectly still. But the mathematics of this space offer a different reality. The pillars are actually in perpetual, twisting motion. By measuring Doppler shifts, the slight stretching and compressing of light waves as matter moves toward or away from us, astronomers have tracked the radial velocities of the gas. These measurements prove that the long columns are slowly rotating. They are engaged in a silent cosmic pirouette, shearing and twisting over millions of years. Simultaneously, the outer surfaces of the columns are boiling away into the dark. The ionized hydrogen gas escaping from the edges is radiating outward at an expansion velocity of 10 to 20 kilometers per second. It is a slow-motion evaporation, entirely invisible to the naked eye, but calculated with absolute precision by the instruments we have sent into orbit. Allow your awareness to shift toward the high-energy spectrum of the cosmos. In the years 2001 and 2007, the Chandra X-ray Observatory mapped this region to seek out the most extreme temperatures. X-rays are typically emitted by matter that is superheated to millions of degrees, such as the energetic coronas of young stars. Chandra's sensors revealed a sky glittering with bright X-ray sources, entirely originating from the 1 to 2 million-year-old stars in the overarching cluster. Yet, when Chandra looked directly at the dark, dusty, evaporating gaseous globules at the tips of the pillars it found almost total silence. The EGGs emit virtually no X-rays. This data confirmed exactly how young and cool the protostars inside truly are. They have not yet generated enough internal heat or magnetic friction to broadcast high-energy light. They are peacefully incubating in the cold. Astrophysicists have cataloged exactly 73 of these specific evaporating gaseous globules scattered across the tips of the main pillars. Despite the massive scale of the cloud, star formation is incredibly selective. Observational data reveals that only about 15% of these 73 dense pockets actually contain young stellar objects. The vast majority of the globules are barren, slowly eroding away without ever igniting a star. It is a testament to how precise and delicate the balance of gravity, pressure, and temperature must be to spark a new sun. In 2012, the European Space Agency's Herschel Space Observatory mapped the entire region in far infrared wavelengths, peering even deeper into the thermal properties of the dust. Herschel's highly sensitive instruments confirmed the exact temperature gradients across the columns, mapping the transition from the relatively warmer edges, struck by starlight, down into the freezing core of the cosmic shadow. It provided a perfect thermal map of an environment taking thousands of lifetimes to gently shape itself. Yield to the quiet realization that you are witnessing an era of the universe that is slowly, gracefully transitioning. The physical forces at play, the sweeping rotation measured by Doppler shifts, the 20 km/s expansion of ionized gas, the protective shadow of the dense tips, are all perfectly balanced equations playing out in the dark. It is a boundless theater of physics, operating with a soothing, predictable rhythm. As the organic soot drifts through the hard vacuum and the hidden protostars gather their mass, the cosmos continues its unhurried work, wrapping you in the comforting certainty of its endless clockwork. We resume our peaceful drift alongside these cosmic monoliths, turning our attention to the invisible forces holding them together. Picture the way ordinary iron filings behave when you slide a standard bar magnet underneath a sheet of paper. Almost magically, the scattered metallic dust instantly snaps into organized, sweeping curves, tracing the unseen lines of magnetic force. Scientists mapped this exact same beautiful phenomenon inside the pillars of creation. In the year 2018, using the James Clerk Maxwell telescope perched atop the dormant volcano of Mauna Kea in Hawaii, astronomers utilized a highly specialized instrument known as POL2. They discovered that the microscopic dust within the pillars is highly polarized. This means the particles are aligning perfectly with a vast, invisible network of magnetic fields looping through the cold gas, quietly holding the towering shapes together like an invisible, comforting embrace. Shift your focus upward for a moment, toward the brilliant, unseen sculptors of this monument. The star cluster NG C6611, positioned just above the pillars, is not just a random scattering of light. It contains a rare and powerful classification of celestial bodies known as O-type stars. These stellar giants are blindingly luminous, with some shining up to 1,000,000 times brighter than our own sun. They act like brilliant cosmic searchlights, cutting through a dense coastal fog. Yet, despite their overwhelming power, they are part of a larger, quiet community. Astronomical surveys calculate that NG C6611 contains approximately 8,000 stars in total, peacefully spread across a volume of roughly 14 light-years. Think of it like a small, tranquil mountain village on Earth, where each glowing hearth is separated by miles of quiet, snow-covered forest. Observe how these bright, hot stars interact with the cold towers below. Despite their immense and towering appearance, the pillars are ultimately ephemeral. In C. By carefully tracking the rate of photoevaporation, astrophysicists have calculated that these massive columns are shedding material at a rate of approximately 70 solar masses every single million years. At this steady, unhurried pace, the entire structure will completely evaporate into the surrounding galaxy in roughly 3 million years. Think of a thick icicle hanging from a roof on a quiet winter morning, slowly and steadily dripping away as the ambient warmth of the sun gently rises. The pillars are melting into the interstellar medium in exactly the same way, just operating on a timescale far beyond human comprehension. There is no rush, only a serene, inevitable transition of matter. Focus now on the varying heights of the columns, like giant stepping stones suspended in the dark. The pillar on the far left is the largest, each stretching a full 4 light-years from base to tip. However, the middle pillar hosts a feature of extraordinary fragile beauty. Protruding from its side is a distinct, delicate wing-like structure that astronomers affectionately refer to as the fairy. This solitary sweeping feature alone stretches for a staggering 0.7 light-years across. To ground that massive distance in something familiar, imagine placing our sun at one tip of the fairy's wing. The nearest star to Earth, Proxima Centauri, wouldn't even reach the other side. As we glide through this serene, shadowy architecture, we must understand the precise recipe of the clouds brushing past us. The ratio of material here is remarkably consistent. For every 100 parts of molecular hydrogen gas, there is exactly 1 part of cosmic dust by mass. It is remarkably similar to the act of dissolving a single small pinch of fine sea salt into a large crystal-clear pitcher of water. The dust is a tiny fraction of the whole, yet it is responsible for capturing the light and painting the magnificent shadows we see. And what exactly is this cosmic dust made of? Spectroscopic analysis reveals a heavy concentration of materials known as amorphous silicates. To bring that complex term down to everyday experience, amorphous silicates are the exact same fundamental chemical building blocks that make up the soft quartz sand you might walk barefoot upon at a calm ocean beach. Except here, the sand grains are infinitesimally small. Each particle measures less than 0.001 millimeters in diameter. You are floating through a suspended, weightless beach, where the sand is so impossibly fine, it behaves like a liquid shadow. Consider the delicate physics required to turn this microscopic dust into a massive, burning star. In 1902, the British physicist Sir James Jeans formulated a mathematical concept, now known as the Jeans mass. It calculates the exact critical mass required for a cold cloud of interstellar gas to finally collapse under its own gravity. Think of a fully inflated balloon. The air pressure inside pushes outward, keeping the rubber tight and smooth. In the nebula, thermal gas pressure pushes outward in the same way. But once a pocket of gas gathers enough mass, crossing the threshold of the Jeans mass, the inward pull of gravity gently overpowers the outward pressure. The balloon yields. The cloud quietly collapses inward, packing the amorphous silicates and hydrogen together until a new star is born in the dark. There was a moment in recent scientific history when we believed this quiet sanctuary might have already been violently erased. In 2007, the Spitzer Space Telescope peered into the region and detected a massive expanding shell of superheated dust, measuring roughly 20 light-years wide. Based on this thermal signature, astronomers initially hypothesized that a massive star within NGC 6611 had exploded in a supernova approximately 6,000 years ago. They theorized that the resulting shockwave had already toppled the pillars, and that we were merely looking at a ghost image of a ruined structure, like hearing the rolling thunder long after the lightning has struck. By the year 2015, the cosmos offered a gentle correction to this dramatic theory. The high-resolution data from the Hubble Space Telescope allowed scientists to precisely track the movement of the gases using a 20-year baseline of continuous observation. By comparing images from 1995 to 2015, they discovered absolutely no evidence of a violent shockwave tearing through the columns. The superheated dust shell was not the result of an explosive supernova. It was simply the accumulated warmth of stellar winds blowing steadily from the massive stars over millennia. It is akin to a slow-moving warm ocean current gently washing over a deep-sea reef, rather than a destructive tidal wave. The pillars remain standing, untouched by explosive destruction, safe in their slow, peaceful erosion. At this very moment, the entire environment around you is governed by the soft rules of celestial fluid dynamics. Because the gas here is incredibly cold and thin, the physical propagation of energy is drastically altered. In the frigid heart of the pillars, the speed of sound, if there was a medium dense enough to carry it to your ears, travels at a sluggish 0.2 kilometers per second. This is significantly slower than the speed of sound in our warm terrestrial atmosphere, which moves at roughly 0.34 kilometers per second at sea level. This shift in physics creates a reality where everything moves with a muffled, submerged grace. Navigating the Eagle Nebula is like waving your hand underwater in a quiet, undisturbed pool at midnight. Every motion is softened, every force is cushioned, and the grand machinery of the universe continues to turn in a beautiful, profound hush. Chum, picture this intimate truth as we float beside these towering monuments. The distance between you and this distant cosmic nursery is only an illusion of space. In the grandest sense, you are looking into an ancient mirror. The elements that make up the very fabric of your body, the quiet room around you, and the warm blankets resting over your chest were born in a place exactly like this. By understanding the slow, beautiful mechanics of the Eagle Nebula, you are unraveling the story of your own creation. Deep within the blazing cores of massive O-type stars, like those scattered throughout the NGC 6611 cluster above the pillars, the universe operates an unfathomably powerful furnace. Through an elegant continuous process known as stellar nucleosynthesis, simple atoms of hydrogen and helium are crushed together under immense gravity and extreme heat. This nuclear fusion gradually forges all the heavier elements required for life, including the carbon in your cells and the oxygen you are breathing in this exact second. Consider the gentle, rhythmic beating of your own heart right now. The iron coursing peacefully through your veins, binding flawlessly to oxygen within your hemoglobin, is a highly specific atomic isotope known as iron 56. This heavy, stable element cannot simply manifest in the cold vacuum of space. It requires the catastrophic, brilliant death of a massive star to form. Every single atom of iron in your bloodstream was synthesized in the final, glowing moments of a dying sun before being scattered into the galactic wind. You are, in the most literal, scientific sense, made of stardust. What's happening now inside these dust columns is a perfect ongoing echo of our own ancient history. Approximately 4.6 billion years ago, our own sun and early solar system formed within an elephant trunk structure, remarkably similar to the pillars of creation. We know this with certainty because scientists discovered the chemical ghost of our nursery hidden in ancient rocks. Meteorites that have crashed to Earth contain the specific decay products of a radioactive isotope called aluminum-26. Because aluminum-26 possesses a relatively short half-life of exactly 717,000 years, its presence proves a massive, short-lived star must have exploded right next door to our forming sun, seeding our newborn solar system with vital heavy elements before fading away into the dark. Imagine a master glassblower carefully passing a glowing, molten sphere of glass from one tool to another, keeping it warm and shaping it before it can cool. The universe handed the raw, glowing materials of life from one collapsing star directly to our forming solar system, a delicate cosmic inheritance passed safely across the void. You are the result of that unbroken chain of warmth. Notice how the frayed tips of the nebula's pillars cradle those dark, dense pockets of molecular gas. Tucked safely inside those shadows, young stars are currently gathering spinning halos of material known to astrophysicists as protoplanetary disks, or proplyds for short. Through the lenses of the Hubble Space Telescope, astronomers have documented these swirling disks stretching up to 1,000 astronomical units across the dark. To truly feel the weight of that measurement, remember that one single astronomical unit represents the precise distance between the Earth and our Sun, approximately 92.96 million miles. These spinning proplyds are incomprehensibly vast platters of raw potential, where tiny dust grains slowly bump and stick together in the quiet, eventually building the rocky cores of brand new, undiscovered planets. At this very moment, resting quietly in your bed, your physical body is composed mostly of water. The journey of those specific water molecules offers perhaps the most profound comfort of all. In the freezing, shadow-drenched depths of molecular clouds, like the Eagle Nebula, ambient oxygen atoms constantly bind with hydrogen to form thick layers of interstellar water ice over the dust grains. When planetary scientists closely analyze the water in Earth's oceans, they measure the ratio of heavy water, which contains a special isotope called deuterium, to regular water. This precise isotopic ratio perfectly matches the signature of water ice found drifting in deep interstellar space. This means a significant portion of the water inside your body, hydrating your cells and keeping you alive as you rest, is actually older than the sun itself. You are quite literally filled with ancient cosmic ice, melted and warmed by the hospitable glow of our local star. To completely ground our place in this sprawling, peaceful architecture, we must map our stellar neighborhood. The pillars of creation reside far away, within the sweeping starry band of the Sagittarius arm of our Milky Way galaxy. Meanwhile, our little solar system journeys safely through a neighboring smaller branch, known as the Orion Spur. The physical distance bridging our home and this glowing nursery is roughly 6,500 light-years. Yet, despite this vast separation, we are all sweeping through the cosmos together, anchored by the same gentle physics. The Milky Way operates like a colossal, slowly spinning pinwheel. It takes our sun roughly 225 to 250 million years to complete one full, sweeping orbit around the supermassive black hole at the galactic center. A profound duration of time that astrophysicists officially call a galactic year. If we measure time by the turning of the galaxy, the Earth is only about 20 galactic years old. There is an immense comforting patience in that scale. Our planet is still young, still quietly spinning through its early years in the infinite dark. Scientists discovered that the dark, silent clouds of nebulae are not merely empty storage spaces for cold dust. They are highly active, floating laboratories. Over billions of years, ambient ultraviolet radiation gently and persistently processes the simple frost coating these dust grains. This slow, frozen chemistry transforms basic inert molecules into incredibly complex organic compounds. We have tangible physical proof of this process, falling gracefully from the sky. On September 28, 1969, a pristine space rock known as the Murchison meteorite fell to the ground in Victoria, Australia. When chemists carefully sliced it open and analyzed its ancient interior, they found over 70 distinct extraterrestrial amino acids hidden inside the stone. Amino acids are the fundamental building blocks of proteins, the exact same biological structures that make up your muscles, your hair, and the spiraling ladders of your DNA. The cold, quiet void of space is constantly, effortlessly manufacturing the invisible seeds of life, scattering them across the galaxy like dandelion spores on a gentle breeze. As we observe the intense stellar winds pushing against the edges of the pillars of creation, slowly eroding the gas over millions of years, we can find deep comfort in the knowledge that our own star provides a similar yet deeply protective force. Our sun continuously projects a steady, rushing stream of charged particles outward into the void, inflating a massive magnetic bubble around our solar system, known as the heliosphere. This invisible, comforting shield stretches far beyond the icy orbit of Pluto. It pushes back against the interstellar medium, safely deflecting harsh cosmic rays and keeping our fragile planetary ecosystem secure. On August 25, 2012, the Voyager 1 spacecraft, a tiny metallic emissary launched by humanity, officially crossed the outer boundary of this protective bubble, a threshold known as the heliopause. It became the very first human-made object to sail out of our solar system and into the pristine, uncharted waters of interstellar space. As it drifts silently through the dark, it carries a golden phonograph record, an artifact etched with the sounds of Earth's wind, our music, and our greetings. It is a quiet testament to our existence, slowly drifting through the same dark ocean that connects us to the great pillars. Yield to the deep tranquility of belonging to such a beautifully ordered system. You are not separate from the sweeping arms of the Milky Way, the swirling protoplanetary disks, or the ancient drifting ice. You are the universe's most elegant creation, a complex collection of stardust that has gently assembled itself over 13.8 billion years, just to experience the warmth of a bed and the peaceful rhythm of a slow, resting breath. Let the vastness of this reality hold you, offering the supreme comfort that everything in the cosmos is unfolding exactly as it should, bound by gravity, wrapped in darkness, and infinitely safe. We glide further into the tranquil architecture of this molecular sanctuary, turning our focus to the deepest nature of the sensory environment surrounding us. The iconic, rich ruby-red glow that illuminates the edges of astrophotography is not merely a painted hue. It is a highly specific physical signature known as the H-alpha emission line. Delve into the precise mechanics of this light. Deep within the nebula, a solitary atom of hydrogen absorbs invisible ultraviolet energy from the distant stars, causing its single electron to become momentarily excited and jump upward into a higher, unstable orbit. But the universe always favors a state of rest. In a tiny fraction of a second, that electron gracefully falls back down from its third energy level to its second. As it settles into this lower, calmer state, it releases a single perfect photon of light. This photon possesses an exact, unchangeable wavelength of 656.28 nanometers. It is a cosmic absolute. Imagine a majestic grand piano stretching across the void, where striking one specific key always produces the exact same warm, red resonance. The entire glowing border of the cloud is simply the visual music of countless electrons, simultaneously finding their way back to a state of peace. To grasp why the inner cores of these columns appear pitch black to human eyes, we must observe the delicate physics of light scattering. Visible light waves, the kind our eyes naturally evolved to process on Earth, measure strictly between 400 and 700 nanometers in length. By pure, quiet coincidence, the microscopic grains of cosmic dust drifting in these pillars share that exact same dimensional scale. When a visible light wave encounters a dust grain of its own size, a process known as scattering occurs. The light strikes the particle and scatters chaotically in all directions, completely unable to penetrate the thick veil. Yet infrared light behaves entirely differently. Infrared waves stretch far longer, easily exceeding 1,000 nanometers in length. Visualize long, gentle, rolling ocean swells, effortlessly passing by a tiny wooden buoy, while the small, choppy surface ripples crash against it. The long, soothing waves of infrared energy wash right over the microscopic dust without any interference, allowing our specialized telescopes to peer peacefully through the shadows and witness the sleeping stars glowing softly inside. Examine the physical texture of the dark material floating silently past you. It is easy to imagine it as soft, formless soot, but the chemistry reveals something startlingly beautiful. Utilizing infrared spectroscopy, astronomers have successfully identified the spectral fingerprints of specific microscopic crystals drifting in these star-forming regions. Among these is a stunning, magnesium-rich silicate mineral named forsterite. On our home planet, forsterite is a type of olivine, the exact same gemstone that creates the sparkling olive-green sand beaches of Hawaii and the glittering peridot crystals found deep within Earth's mantle. In the extreme environment of a stellar nursery, these pristine crystals are initially forged near newly ignited protostars at searing temperatures approaching 1,000 Kelvin. Over millennia, the stellar winds gently exhale this crystalline dust outward into the deep freeze of the nebula, cooling it down to a dormant 10 Kelvin. You are floating through a suspended, weightless storm of microscopic green gemstones, glittering silently in the cold dark. Shift your awareness from what you can see to what you might theoretically smell, bridging the gap between cold mathematics and intimate human senses. Giant molecular clouds operate as slow, vast chemical factories. Radio observatories scanning these deep space regions analyze the faint spinning frequencies of complex molecules. One of the most fascinating discoveries in dark interstellar nurseries is the abundant presence of an organic ester known as ethyl formate, carrying the exact chemical formula C3H6O2. On Earth, this specific molecule is uniquely responsible for the tart, familiar flavor of fresh raspberries, and it provides the sweet, distinct aroma of poured rum. While the vacuum of space is completely devoid of breathable air, the raw, frozen ingredients suspended in the dark carry the ghostly chemical perfume of a terrestrial orchard. The comforting void is not a sterile wasteland. It is brimming with the sweet, dormant building blocks of organic life, patiently waiting for a star's gravitational warmth to thaw them into motion. Feel the sudden, invisible boundary separating the cold dust from the glowing void. At the very edge of the pillars, where the dark gas meets the bright surrounding star cluster, exists an extreme environmental threshold called the ionization front. The temperature contrast here is staggering, yet deeply silent. The dense molecular gas inside the shadow rests at a frigid 10 Kelvin. But step just across the invisible line into the halo of ultraviolet starlight, and the thin ionized plasma surges to a blistering 10,000 Kelvin. On this dramatic temperature cliff occurs across an impossibly thin boundary, often spanning no wider than the physical diameter of our own solar system. An intriguing aspect of this 10,000 Kelvin plasma is how it interacts with the physical world. In the near vacuum of space, the scientific definition of temperature measures the kinetic speed of particles, not the convective heat you would physically feel on your skin. The density of the ionized gas here is astonishingly low, containing roughly 3,000 atoms per cubic centimeter. If you were completely exposed to this roaring 10,000 Kelvin plasma, you would not burn. In fact, because there are far too few particles to transfer their energy to your body, you would rapidly freeze. The danger is nullified by the vastness. Along this glowing shoreline, another deeply soothing atomic process is occurring. When a free-floating proton in the hot plasma gently captures a wandering electron, a phenomenon known as recombination takes place. The two charged particles finally embrace, settling down to form a neutral hydrogen atom and releasing a soft pulse of light in the process. The glowing halos of the columns are nothing more than a continuous, serene cascade of atoms, finding each other in the dark, binding together, and sharing their microscopic warmth with the universe. Listen closely to the absolute silence of the vacuum and consider how science translates that profound quiet into understandable data. Because the darkest, coldest regions of the nebula do not emit any visible light, astronomers must rely on an entirely different kind of signal. Molecular hydrogen is notoriously difficult to detect when it is freezing. Instead, scientists utilize the carbon monoxide molecule as a reliable tracer gas. CO molecules are naturally asymmetrical, and as they tumble and rotate in the cold vacuum, they emit a very specific steady radio frequency at precisely 115 gigahertz. Telescopes on Earth tune into this invisible broadcast to safely map the hidden contours and densities of the cloud. While our human ears cannot perceive electromagnetic waves, if you were to transpose this steady 115 gigahertz frequency into an acoustic vibration, the pillars would produce a deep, continuous, resonating hum. Imagine a colossal, silent lighthouse steadily broadcasting a low, comforting foghorn through the vastness of a midnight sea. That low, invisible drone is the true heartbeat of the cloud. It is a persistent rhythm of rotation, echoing out across thousands of light years, providing a gentle assurance that even in the darkest, coldest shadows of the universe, the mechanics of creation are endlessly awake, slowly turning and keeping perfect time. Observe the grand machinery of this celestial theater as we gently bring our cosmic observation to a quiet, comforting halt. The towering silhouettes of the Eagle Nebula, formally catalogued by its surrounding emission cloud as IC4703, are slowly retreating into the dark as our journey nears its end. To truly appreciate the peaceful endurance of this space, trace the precise, step-by-step process of how a star finally awakens within these shadows. It is not a sudden, violent event, but rather a profoundly slow, methodical sequence of physical transitions that takes millions of years to unfold. It begins when a localized pocket of microscopic dust and hydrogen gas reaches a critical density. Initially, this dense knot has no internal heat of its own. As gravity pulls the material closer together, the cloud steadily shrinks. During this phase, a phenomenon known as the Kelvin-Helmholtz mechanism takes control. Through this exact physical process, the sheer mechanical energy of the cloud compressing inward under its own weight is slowly converted into thermal radiation. The gas is gently heated by gravity alone, creating a warm, glowing sphere in the dark, a protostar. Gradually, this protostar enters a transitional period classified as the T Tauri phase. For a star roughly the size of our own Sun, this pre-main sequence stage lasts for approximately 10 million years. During the T Tauri phase, the young star is intensely active, but fundamentally incomplete. It still lacks the necessary core pressure to maintain true nuclear fusion. Instead, it continues to slowly, patiently contract, gathering more mass from its surrounding planetary disk, waiting for the precise threshold of temperature to be breached. The final defining step of stellar creation happens deep within the invisible core. When the center of the protostar achieves a staggering internal temperature of exactly 15 million Kelvin, a permanent atomic shift occurs. At this exact thermal boundary, hydrogen protons are moving with such intense kinetic velocity that they overcome their natural magnetic repulsion. They collide and fuse to become helium. A star is officially born. It enters the main sequence, the stable, longest-lasting chapter of its life, where a star, like our Sun, will reside peacefully for 10 billion years. Deep within the remaining 200 solar masses of dust, lingering in the pillars, the universe is currently assembling a very specific, quiet type of star. The majority of the material here will go toward forging M-type stars, commonly known as red dwarfs. Trace the timeline of a red dwarf, and you will find the ultimate expression of cosmic patience. Because they possess only a fraction of our Sun's mass, their internal fusion process operates at an incredibly sluggish, highly efficient pace. A standard red dwarf burns its hydrogen so slowly that its estimated lifespan stretches up to 1 trillion years. Consider the profound mathematics of that timeline. Our entire universe is currently measured to be only 13.8 billion years old. Because of this, not a single red dwarf ever created in the history of the cosmos has ever died. Every single M-type star, born in the earliest days of the galaxy, is still quietly shining today. And the ones currently forming in the cold heart of these pillars will outlast nearly everything else in the night sky. There is unparalleled comfort in this kind of longevity. It is a slow, enduring warmth that simply refuses to rush. Now, follow the journey of the light radiating from these newborn stars as it completes its final physical process, traveling across the void to reach human awareness. A single photon departs the nebula, crossing the vacuum of space at the absolute cosmic speed limit of 299,792,458 meters per second. After a serene, uninterrupted flight lasting 6,500 years, this light arrives at the golden mirrors of the James Webb Space Telescope. Webb's massive hexagonal reflectors are coated in an impossibly thin layer of real, elemental gold, measuring exactly 100 nanometers thick. This highly specific metallic plating is designed to perfectly capture and reflect infrared wavelengths, translating invisible cosmic heat into a digital map. The process continues as that digital data beams down to Earth, ultimately arriving at your own human biology. As you look at the brilliant images of the cosmos, the light enters your pupil and strikes the retina at the back of your eye. The human retina is a biological marvel, equipped with roughly 120 million specialized photoreceptor cells, known as rods. sculpts designed specifically to detect the faintest traces of light in the dark. Once the rod cells capture these photons, electrical impulses travel down your optic nerve to the visual cortex, located in the occipital lobe at the very back of your brain. This entire neurological translation is completed in approximately 13 milliseconds. The light of a trillion-year star finishes its ancient, sprawling journey within a fraction of a heartbeat, resting safely inside your mind. As we pull our focus away from the distant stars and return entirely to the quiet sanctuary of your room, observe the biological sequence of sleep beginning to unfold within you. The chemistry of human rest shares a beautiful structural symmetry with the interstellar clouds we just explored. Melatonin, the primary hormone responsible for regulating your circadian rhythm and signaling your body to sleep, is built upon a chemical backbone known as indole. Remarkably, astrochemists have detected the exact molecular signature of indole drifting freely within the cold molecular gas of interstellar space. The chemical mechanism guiding you into slumber is mirrored in the very building blocks of the galaxy. Just as the hot plasma of a nebula must cool for a star to safely form, your own physical form follows a precise thermal process to initiate deep recovery. As evening transitions to night, your biological clock triggers a systematic cooling down of your internal systems. Your core body temperature reliably drops by about 1 to 2 degrees Fahrenheit. This slight vital chill signals your metabolic engines to power down, imperfectly mimicking the cold, quiet stillness of an ancient dust cloud settling into the dark. Trace the mechanics of relaxation spreading slowly through your limbs. The tension held in your muscles throughout the day is actively releasing. This physical unwinding is governed by the withdrawal of microscopic calcium ions within your muscle fibers. Every single atom of this calcium, ensuring your body can finally go limp and heavy against the mattress, was originally forged in the extreme heat of a Type II supernova. Furthermore, your nervous system is gradually slowing its rapid firing rate, utilizing a naturally occurring radioactive isotope known as potassium-40 to regulate cellular communication. The ancient stardust woven into your cells is quietly shutting down the day's activity, step by gentle step. On a macro scale, the planetary machinery is working tirelessly to cradle you in darkness. Beneath your resting body, the Earth is engaged in its own ceaseless rotation, spinning on its axis at roughly 1,000 miles per hour at the equator. This smooth mechanical turning is actively rolling your specific hemisphere away from the intense light of our local sun. You are being carried smoothly and silently into the protective shadow of the planet. The universe is physically providing the dark blanket you need to properly heal. Notice the physiological rhythm of your breathing as it shifts into its nighttime gear. Your respiratory rate is steadily decelerating, finding a soft, automated plateau of 12 to 20 breaths per minute, which is the standard baseline for non-REM human sleep. With each exhalation, carbon dioxide, another compound abundantly present in the Eagle Nebula, leaves your lungs, exchanging the elements of your body with the quiet air of your room. Deep within your neurological architecture, a final, soothing transition is taking place. The rapid active frequencies of your waking mind are being replaced by slow, rolling delta waves. These deeply restorative brain waves oscillate at a calm oceanic frequency of 0.5 to 4 Hertz. The electrical storms of the day have passed. Only a slow, rhythmic tide remains. Grant your mind permission to fully embrace the comforting void of sleep. You are fundamentally composed of the same ancient, enduring materials as the stars. The gravity of the Earth is holding you with perfect, effortless safety. There is nothing more you need to calculate, nothing more you need to achieve, and the physics of the universe will continue to operate with flawless precision while you rest. Your cells are quietly repairing, guided by billions of years of biological wisdom. The darkness around you is not empty. It is a supportive, protective presence. Every heavy element in your bones is anchored safely to the present moment. You are deeply, intrinsically connected to the quiet clockwork of the cosmos. Yield completely to the slow rotation of the Earth, sinking into the silence. The stars are keeping watch in the immense peaceful distance. Rest now in the boundless, comforting quiet. Good night.